Our session is unit 7, where we're going to look at forecasting techniques. This is just a build-up to POM or quantitative methods that we already did in our initial stages of our classes. So linear regression is a powerful and widely used technique which helps to understand linear relationships that exist between two or more variables. In its simplest form, simple linear regression. This is one model that helps us investigate how one independent variable, which is a predictor or an explanatory variable, is used to predict the value of a dependent variable, which is a response or an outcome. So the general linear regression equation model that we use is y is equal to bo plus b1 plus e, where y is a dependent variable, the result, and x is the independent variable, the input. Bo is the gradient, is the intercept, and B1 is a gradient, and E is a random error term. So when both variables are transformed using logarithmic, we have this kind of outcome. Now, we use what we call the least square estimation method, which is used to estimate the parameters of the Bo and B1. So when you're dealing with linear regression, we want to estimate the type of relationships that exist between the dependent variables and so we have y and x. Okay, so when we have a regression equation, we have our a, which is the same as b0. This is what we call our intercept, where it's cutting the y-axis. And the gradient, which measures the change of one unit increase in x with relation to one increased unit in y. This is what we call our b1. That is our slope. So together we get a regression equation, which is given by b0 plus b1 x. So our job will be to explain how to calculate these two variables that we can see. So I'll take my time to explain these concepts before we answer question 7. How do we get so far? All right, so we want to now explain the least square estimation. So we have the least square method that was used to estimate the parameters of the slope and the gradient. So to find our slope, we find the sum of squares xy over sum of square xx. And the slope is the mean of y minus b mean of x. So where the sum of xy is summation of x minus mean times summation of y minus y bar, whereas SSXX is summation of x minus the mean squared. So to find summation of xy, we have summation of xy minus summation of x, summation of y over n, summation of xx, we're going to have summation of x squared minus summation of x squared over n. Now, before I go to explaining this, did you go through my video on regression where I use simpler figures? Did you go through that video? Aubrey, Musa, did you go through the video for regression? Or can we do
I
it?
need to go to it
Or
because
can we
I,
do
I,
it
I
in
didn't
this?
attend that class.
All right, okay. So if you have variables, for instance, x and y, so we want to understand the relationship that exists between the two variables. So to start with, the variables x and y can either have a positive or a negative relationship. The positive relationship can be upsloping and the negative relationship can be downsloping. So the relationship that you may expect to have would be as follows. So this shows a positive relationship. This shows a negative relationship. Okay. And this shows no relationship at all. So positive relationship, negative relationship, no relationship at all. So the relationship can be strong if the dots are close to each other. So what determines the strength of the relationship is what we call the R squared, which is the coefficient of determination. Coefficient of determination. The slope can be downsloping, but the curves are still close to each other. This means our R squared is more than 50%. It's given by summation of what? Xy over the square root of xx times yy. If the answer will square it. Before squaring it, we call it the coefficient of correlation. So if there's no square that's the answer. We call it coefficient of correlation. It shows you whether you have a positive relationship or a negative relationship. So coefficient of correlation determines to what extent the dependent variable is affected by the independent variable. So if you're dealing with sales and advertising, the extent to which sales are affected by advertising is measured by R squared, which is a coefficient of determination. So if your R squared is 0.8167, this means that 81.67% of Y is because of X. So it measures causality, how the variables of X affect the variables of Y. On the other hand, the dots can be far away from each other. So this means that the relationship is weak. If your R squared is less than 50%, you have a weak relationship. So the dots can be close, can be further, depending on what kind of relationship. Sometimes there's no relationship at all. The relationship may be between age and performance. All right, there's no relationship. Some who are older are underperformers, some who are younger are overperformers. So the least square method will help us to calculate the extent of the relationship. So what have I said? R is for the direction. R squared is for the strength. All right, how much over X affects Y. So now, that being said, we now need to calculate our values. So we may be given an example of, if I look at this example that we have in here, let me come up with just figures that are simple to follow, that will help us understand the concept. So I'll give you the formulas that I need you to master. So if you have Y and X, we have these values here. We have 1, 2, 3, 4, and 5. And here we have 1, 1, 2, 2, and 4. So with these values, we're being asked to sketch and determine what type of relationship we have, whether it's a negative or it's a positive, whether it's strong or it's weak. So in this context, I can sketch this. So 0, 1, 2, 3, 4, and what? And 5. And here we have what? 1, 2, 3, 4, and 5. Right. So 1, 1, you put it here. 2, 1, you put it here. 3, 2, you put it here. 4, 2, you put it here. And 5, 4, you put it there. So this relationship here you're showing shows you that there's a positive relationship which is strong. But now, the extent of the strength can be calculated. So you're told that the relationship is given by y is equal to BO plus B1 x. Okay, where B1 is equal to what? Summation of the sum of square xy over sum of square xx. But what is the sum of square xx? Sum of square xx is given by summation of x squared minus summation of x whole squared divided by n. What is sum of square yy? Sum of square yy is equal to summation of y squared. Everything is y minus summation of y to the power 2 over n. What is a summation of xy? Sum of square xy is given by summation of xy minus summation of x times summation of y. So there's xy everywhere over n. So how do we find the b, which is the slope? It's xy over xx. How do we find our r? Is xy is similar to what is on top? Is xy over square root of x times yy more square yy. And how do we find the gradient b0? B0 is simply given by summation of y over n minus a b we just calculated, summation of x over n. So now let's calculate all these. I want us to find the regression equation. I want us to find the r. I want to find the r squared. And also, we need to predict the equation. This is what we are destined to do. So, given the parameters x and y, let's find xy. Let's find x squared. Let's find y squared. So what is xy? You're simply multiplying this by that. 1. This by that. 2. This by that. 6. This by that. 8. This by that. 20. Then we're squaring x is alone. What is 1 squared? It's 1. 2 squared? 4. 3 squared? 9. 4 squared? 16. And 5 squared is 25. Let's go to this column A. What is 1 squared? 1. 1 squared? 1. 2 squared is 4. Another 2 squared is 4. And 4 squared is what? 16. Are we together so far?
Yes, we are following.
All right. So we now go into calculating the summations. So here is summation of x, summation of y, summation of xy, summation of x squared, and summation of y squared. So what totals are we getting?
47.
Okay, so you've seen the totals? We're just totaling up here. You've seen the totals? Summation of
Yes, yes.
15,
Yes.
summation of y 10, to all these. Now, let's estimate summation of xx using these parameters here. So xx with what? Sum of square xx. What's the formula? X squared, which was 55, minus what? X to the power 2, which is 15 squared, over n. Our n is what? 5. So 55, 15 squared over 5 is 45. So 55 minus 45 is what? 10. It's according to formula 1. Formula 2, let's find y. These are just preliminary calculations. Y. What is y squared? 26. Then y to the power 2, 10 squared over 5. So this is 26 minus 20. What's 26 minus 20? Which is 6. Okay. So let's go to xy. What's the formula for xy? It's xy minus x and y over n. So what is our xy? It's 7 minus what? 15 times 10 over 5. What do we get? That's 7 minus 30. What's the 7 minus 30? 7. So we have almost everything. So now how do we find our, and we already know here, our summation of x is what? 15. Our summation of y is what? 10. Our summation of xy is what? That's 7. Our summation of x squared is what? 55. And our summation of y squared is what? 26. Are we together so far? And our n was what?
Yes. Yes.
Our n is what? 5. So how do we find the b? Our slope, our b1, summation of xy over what? xx, right? What is our xy? 7. What is our xx? 10. So our slope will be 0.7. Are we together? Then that's the
Yes.
formula for b0, summation of y over n minus b1, summation of what? X over n. That is our summation of y is what? 10 over what? 5 minus the b1 was 0.7. The summation of x was what? 15 over what? 5. Are we following? So this
Yes.
will be 2 minus 0.7 times what? 3, which is 2 minus 2.1. What is 2 minus 2.1? Meaning our B0 will therefore be negative 0.1. So we just replace it here. Find the regression equation. So what is our regression equation? Y is equal to what? Our B0 is what? Negative 0.1. Our B1 is what? 0.7. So this is our prediction equation. You do that. Are you together? You're just replacing what your B0 is and our B1 is. And then they'll ask you, predict Y when maybe X is 10. Just replace Y there's X here, put 10. That is the whole reason for forecasting. Okay? You want to know a project in project finance, for instance, if you're going to put 10 billion, what is your expected sales? Okay? So what? Just giving hypothetically, if we thought that our X is 10, what is our Y? Our Y becomes what? 6.9. Then our R stands for the coefficient of what? Correlation. It measures how the direction is. The formula is xy over xx times yy square root. So our xy was what? What was our xy? Was 7, right? So 7 over square root of what? Xx is what? What was our xx? 10. 10 times 6. So when you calculate that, we're going to find 0.903. So this means that it is a positive relationship. We're interested in the sign. Then R squared is when you square that answer, you're going to get 0.8167. So what does this mean? 81.67% of Y is because of X. Are we together? X is due to the variation in that X. So this is basically what our question 7 is trying to ask us to do. Of course, I've just slightly made the formulas simpler. So when you go to our question here, so we are looking at what? The banking analyst believes that living space S measured by square meters is a good indicator of price P of the property. The analyst produces the figure of 200 properties listed in the city there. So let's comment on the graph. What is our comment on the graph?
So it has it's a positive relationship.
Okay. Yeah, it's a positive relationship. So it shows a positive relationship, strong relationship. Okay. So the banking analyst fits the least square regression line for Y on P, where given summation of X, summation of X squared, summation of Y squared, okay, XY, the mean of X, the mean of Y. Okay, you've been given how to find X, Y, Y. These formulas I gave you, remember these formulas, right? Okay, so, and the slope will be XY over XX, and the slope for Y is mean of Y. It's the same as summation of X over N. Okay, so now we want to determine the least square regression line. So how do you find the least square regression line? And there, you first calculate the preliminaries. Okay, so how do we find the least regression line? So we use what? The parameters that we have there. So I need you to answer that on your own. I'll just guide you through. So our values of x, the mean of x is 9.6 over 20. Our n was 20. Mean for y is 5.4 over 20. Then our summation of xx, we're already given this, so we calculate the value of xx, which is this one, the value of yy, which is this one, and the xy, all right. Then the slope is simply given by xy over xx. So you divide your answer, xy over xx, you get 1.05. And the slope, what is the formula for the slope? Summation over y over n minus b, summation of x over n, which is just the slope of each of them. So the answer we found there, we substitute, we get that. So this is our b1 and our b0. So meaning the regression equation will therefore be equal to what? b0, which is 0.641 minus 1.050, okay, x. So this is our regression equation. We're going to leave it in logarithmic form in terms of, because our y is the price and our s, according to our guide, stands for the living space. So we're going to express them in terms of what? P and S. So, and introduce logs. So in my module notes, I told you that how to convert to logarithmic function, you just introduce the logs there. So our regression equation, which was y is equal to b0 plus b1 e, when you introduce natural logs to each of them. So here we're going to have a ln y, b0 plus b1 ln x. Okay, so this simply means that in the equation, we're going to convert this to logarithmic form. So this would be ln p 0.641, 1.05 ln s. So this is our regression equation. Are we together so far?
Yes. So the sign there changes to positive.
No, it was positive already here. Sorry,
Okay.
with my error. It was positive already. It was a positive gradient there. Is that clear? So
Okay.
the interpretation of that one is that a 1% increase in living space is associated with a 1.05 increase in price uh, on average. So increase in living space is associated with a 1.05 increase in living. So you need to interpret that. So 1% increase in living space is associated with a 1.05 increase in what? Price on average. So this indicates that there's a slight increasing returns on scale in the housing prices relative to the space. And how do we calculate our R squared? Remember how to calculate our R squared?
Yes. We use the formula for direction, which is SS yx over.
Mhm.
Then after we find the answer, we square the answer.
Square it, yes. So our R is equal to what? SS xy over square root of what? SS xx times what? SS yy. So when you square this, it comes our determination. So meaning the square will come here, and the square root 2, when you square it, it comes out. So our R squared is as good as this. Are we together? This is for R and this is for R squared. Are we following?
Yes.
So,
Yes.
Msanda, is this clear on how this formula has evolved from here to here? In short, you can simply find your R and square it. It's no problem. So when you find your R, just square it. Okay? So you calculate it based on your preliminary calculations. So when you get a figure like that, you need to learn how to interpret it. So usually R is supposed to be within 1 and 0. But if it's greater than 1, it's not a possibility. So meaning you can round it off to 1, meaning it explains that there's a full variation. So there's just an error in the calculation, but it's not possible to have something above 1. So anyway, if we found 1, it means that the model explains all the variables in price are explained by the living space. But if we found 0.8, means 80% of the variables in price are explained by the living space. Okay, so that is to do with question number what? Question number part 2. I'm being asked to find the regression line, the coefficient of determination. And now we want to calculate a two-sided 95% confidence interval for P0. So we're given this. So this is under estimation. So when you're finding an estimate, you're finding a confidence interval. Okay, so that is under hypothesis testing, which I'll teach in the next class. But for now, I just need you to redo question with the figures that are in here to calculate the regression equation. You also find our R and R squared and also predict our our price if the sales are 10,000. So I'll give you the homework based on what we've learned so far. Is that clear?
It's clear, but Collins, maybe what I just want is you just to do the interpretation, because of course I didn't go through the question to understand what we're looking for. I may have understood how to calculate, but maybe what are we trying to achieve, like the interpretation?
So when dealing with regression or forecasting, to start with, the regression equation is used to analyze, because look at the preamble of the question. We believe that the analyst believes that living space measured by S, measured in square meters, is a good predictor of what? Of the price of the property. So we want to see whether how big living space in square meters uh, predicts the price of the property. So the analysts went ahead to sample 200 properties in a big city. And based on the square meters of the living space and the prices there, wanted to now estimate the relationship. So firstly, we're being asked to come up with a relationship between price and the living space. So price is our dependent variable, living space. So does increasing the number of square meters positively affect the price? We can see there it's yes, but by what extent? The extent is when we find our R squared. If we find our R squared as 0.8, it means that 80% of the independent variable X, okay, affects the price, meaning we're 80% sure that 80% of space, living space, is a key factor in determining what? The price of property. Okay? Then R squared will just give you the relationship, whether they are positively related or negatively related. Then suppose you had, because here there's 2,000, 4,000, 6,000. Now I'm asking you to predict. Suppose the floor space was 10,000. What price would it fetch for? So we're using the concept to understand how that the X variable can be used to determine the Y variable. In short, are we together?
Yes.
So I'll redo this question with my questions. Okay, I'll use the same figures, but I want you to help me calculate just in a simple way. I don't want to overcomplicate things. I'm trying to simplify this as much as can be so that we reach. So the latter part of it is under hypothesis testing itself. A whole lot of its own question. So I don't want to confuse you for now. But that's where we've reached. I'm hopeful we are together. So I'll share the video later on in case you need to go through. But I hope this suffices for now.